I work on the business and product side, and today what I'm going to talk about is mostly related to how Flutter builds your apps for Android and for iOS, what CI is doing about getting your app builds faster, and give you some quick tips on what you can do about it. So a little bit about Flutter was from the Google Trends. You could see that if you compare it with just the keywords to Kotlin or React Native, for example, it is quite far up there. It is getting more and more popular, and if you look around in this venue as well. Yep. So the problem that we were seeing was that when you are an Android developer going into cross-platform, you often see your iOS release builds taking a long time. So what I'm doing right now is I was building an app on CodeMagic, which is our CI/CD service specifically for Flutter. And we saw that the iOS build, for example, is taking 42 minutes. And this is clearly a long time. And the app that I was building was actually quite simple. So we made this app called Neverlate, which is like a random excuse generator that we made at Nevercode, which is our data scientist did that. And we made two versions of the app. One version that doesn't use Firestore dependency, and one that does use Firestore dependency. This is not great. But with the Firestore dependency, the build time increased 40 minutes, or 41 minutes sometimes, which is clearly bad. And I made this table to visualize what the specific differences were when you use this Firestore dependency with a really simple application, and what happens when you don't use Firestore dependency. And what you can clearly see is that when you do use Firestore, which is a heavy platform-specific dependency, your build times can go up from an iOS debug build, which used to take 50 seconds, now takes about 20-something minutes. And for the release builds, it takes about 40 minutes, 42 minutes, like you saw before. But the Android one is not affected much. You get from 70 seconds to 120 seconds. That's about from 1 minute to 2 minutes. So you ask yourself, why is this? And coming from an Android world, you may think that, like, why can't we just cache everything? That should speed up builds, right? It's not really the case right now when you go into the iOS realm. So we built our app in Flutter, and how Flutter prepares your iOS builds is that it runs Flutter build commands. And Flutter build commands prepare your iOS code base. So what we're doing is we're preparing the Xcode workspace, and we're downloading all your dependencies as source codes. And Flutter build commands finish with building the .app extension of your application. And the main difference is that right now we have to compile all the dependencies from the source. And we have to do this twice if we are actually targeting a physical iOS device. And with that, we need to run Xcode archive on the Xcode workspace to generate the XC archive, which is kind of like a binary, and then export it into a .ipa extension, which you can distribute into the stores. You can potentially generate an IPA from the .app as well, but you can't distribute it in the app stores. And this is a huge problem, because when you run this Xcode build archive command, you can't use any of the cache. It just builds everything from scratch. You can potentially use cache during the Flutter builds when you're actually building the .app extension with incremental builds, but when you're shipping and distributing your apps, that's not an option right now. So the question is that, I'm sorry. Well, the difference is that when you're building these Android apps, you have precompiled jars that you're using, or AARs. And these you don't have to compile twice. And you have this internal caching mechanism that you can even use when you're distributing your APK files or Android app bundles. And this is really, really useful that you don't have in the iOS world. So what you can do is you should really think about the dependencies that you're using and if there are alternatives to that. So what Flutter actually does when it builds your APK files is it asks for the Gradle for all the building tasks, and then it just executes them. It links the dependencies to your app, whether they're jars, AARs, or native components. No more, no less. So it doesn't have to compile them twice. And this is really useful. And it's also interesting to think about a little bit of the history. How was it always like this? Was Android always faster? Did it always use these precompiled sources? And it wasn't always the case. Back in the day, iOS apps used to be built faster than Android apps. But then when Google started to support Gradle and use it for Android, things got a lot better. But Maven was in the scene as well, and Maven has not even gone away yet. They're still using Maven in the Java world and in the enterprise projects. But the main difference is that Gradle keeps upgrading and Xcode seems to be staying the same. So this is what it looks like when you're building the applications, but what does it look like from a CI perspective? So what can we do to help you build your apps? What do we do to make your builds faster? The first thing that comes to my mind is this picture of the Mojave Desert with the cargo ship there. And this is that you're used to you're basically used to building it on Docker containers, but when you go into cross-platform, you can't build in Docker containers anymore, because Docker runs Linux containers, and you can only build your Android apps there. So when you have to build your iOS apps, you have to look elsewhere. There is a workaround you can use, obviously. If you have Docker containers, you can also mimic like a Docker server. If you have a server.js that mimics a Docker server, you can build outside of the container on the Apple OS, on Mac OS basically, on Apple hardware. But this is not desired. It's kind of a hack rather than an elegant solution. So what we do, for example, at Nevercode is that we use VMware's ESXi, which if you have your Mac hardware, then we have a virtualization layer which works on ESXi operation system. And these are booting up our virtual machines that run on Mac OS, and then we can use these to build your iOS apps. And what's really nice about ESXi is that it supports nested virtualizations. So you can also run your emulators there as well. And what's happening is that we have this control layer that is essentially our CI system that sends jobs onto the virtual machines. And then we have our builders that just execute the jobs. So it works really nicely. But there are a couple of downsides as well. It's not always that nice. Essentially, when you're using this VMware's ESXi, what is happening is that it's not native in a sense to Mac OS or Mac hardware, because you can't have ESXi operation system on the newer Macs, because they have the T2 chip. If you disable the T2 chip, what you can do is you can boot up the operation system with USB connection, but you can't use the SSD in this case. So it's kind of a trade-off. You have to use the older versions. Another thing is the base images, that they're quite large and they take up a lot of the disk space. But the really nice thing that if you do use VMware's ESXi is that you support the nested virtualization. So if you have driver tests or instrument tests, you can run them on the emulators. So what are some of the alternatives to this? Because obviously the iOS is a problem. And if you are looking for alternative virtualization methods, and I'll show you how these work as well, and what the results are, one option is to use Anka, which is by Vertu. So Anka is quite nice. When we're thinking about VMware's ESXi, which is like this operation system that you generate Mac OS VMs, then what Anka is it's a desktop application, essentially, which you have on your Mac OS. And it's essentially called Anka Build. And Anka comes with two other components as well, Anka Controller and Anka Registry. So what Anka Build does is it boots up a virtual machine, which is essentially the Anka nodes. And you have Anka Registry, which distributes virtual machines onto these nodes. And then you have the Anka Controller that provisions those VMs, and your CI system that sends jobs through the controller onto the nodes. And what's really nice about Anka is that it uses mostly local storage. And when you have like a Mac Pro, for example, that has multiple VMs running on them, the disk space is quite low because it utilizes local storage. So when they build these new VMs on top of them, they use the deltas rather than the whole base image, which is quite nice. Another thing that's really good about Anka is that when you use those base images, then you also always have to re-image them. But when you use an application, you just have to update the software. So it also eliminates this option that your service is down sometimes. Another really good thing about Anka is that it comes with this some Docker-like command line tools. So in Anka, what you do is similar to when you have Docker execute, you have Anka run, which is quite nice. But one of the reasons why everybody is not using them is because you have to deal with the licensing. And the licenses for Anka are quite expensive. But if you really, really need to have really fast iOS builds, you can use Anka. Essentially, the licenses work per core that you are using, and it kind of adds up. But how does it actually affect the build speed? So when we were building our Nevercode application that had the Firestore dependency, it used to take 40-something minutes. But when you use this Anka, it takes 24 minutes. And this is quite significant. So you have this comparison. When we have VMware's ESXi, it takes about 20 minutes for the iOS debug builds and about 40 minutes for the iOS release builds. But with Anka, it takes about 20-something minutes for the release builds, and it takes about 10-15 minutes for the debug builds, which is quite significant. It's about 40% difference. And a couple of companies that are using this, Shopify, for example, they're using Anka to scale up their iOS CI/CD service, and Cirrus CI as well is using Anka. Another one that's really interesting is from Mac Stadium that came out, this virtualization technology that came out actually recently after the iOS conference, which is called Orca. And Orca, it's currently in beta. You can get access to it if you'd like. I think they have 1 month free trials, and you can extend it to 2-3 months if you'd like as well. We haven't tried it yet, but we're really interested in it, and we want to try it. What it's doing is it's using CentOS to create these container-like virtual machines. I'm not sure how to call it. It's like para-virtualization or containerization. It's something in between. But what's nice about it is it uses the Kubernetes control layer as well, and you have the storage area network that you could use. And it's a really very promising technology. It's something that we are interested in and we want to try out. So if you're interested in trying out different virtualization methods as well, you can take a look at what Orca has to offer. But in general, if we're talking about this building from scratch or caching everything idea, then the trouble is that even when you have a CI system and you're building everything again, then what you can do, for example, what Shopify does is after the build finishes on the VM, it saves the template. And then the Anka controller, it saves the state, and then it has a template VM that it only uses the delta dependencies or deltas to run your builds, which is quite fast. But the problem is similar to when you have caching on your local machine. Then what is happening is that you often run into this problem of what if your non-delta dependencies get updated or the services are no longer available? So it is important to build stuff from scratch. And oftentimes what we see is that developers come to us and say that, the builds are fine on their local machines, but when they come to the CI service, then it no longer works for them. So then you have to ask the question that what if your laptop falls in the river, then you can't make a new one, and then everything can be lost. And then it reminds us of something like this. But to give you some quick tips on how you can save time is to build in parallel, not together. So for example, if you're building for cross-platform technologies, set up different workflows to build your Android on one workflow, iOS in another workflow, and web, for example, in a third workflow if you're using Flutter. Nightly builds are really useful, especially if you have a QA team and you have your emulator or driver tests. You run nightly tests or nightly builds, and then when the QA comes to work, they have all their results there. If you do need to build faster and you have these heavy dependencies, then a couple of things you can consider is upgrading your hardware, going to Mac Pros, for example, or you can try different virtualization or containerization methods. The ones that I mentioned were Docker, Orca, and Anka. And in general, what we see is that, I'm sure you're familiar as well, is that Docker is really, really useful. It's lightning fast, basically. If you can use it, but the trouble is with the maintenance, if you have different infrastructure components. So if you do have your iOS CI separately than your Android CI, if you're a startup, it's not easy to scale it. But in the end, it is important to experiment. So for us, for example, what we try to do is build this stateless builder servers and stateless builder machines. So if we do have all these options available for us, the VMware, Anka, or Docker ones, then we can always change between all three of them and experiment with them. But the problems arise when you, for example, we saw that Anka is about 40% faster. The problems arise when you try to make a business case out of it and you try to make it affordable for everybody. Then you have to come up with these creative solutions. So that's why at the moment we don't offer this. But on Cirrus you can get it. But these were the main things that I wanted to show you, is that if you are building both Android and iOS apps, and your iOS apps are using these heavy dependencies like Firestore, they do have to compile twice, and you may have to consider choosing different dependencies. Whereas if you're building on Android, you have everything pre-compiled, so you don't have to do it twice. But thanks. My name was Martin. If you have any questions, I'll try and answer them.